Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the following equation is true. Meaning, we are provided here with an equation, and we need to show that this is true for any natural number. So how shall we proceed? Let us begin. So first, what we'll do, we're going to consider a statement Pn. So let Pn be a statement such that we can represent the statement P of n as we take the first term 1 over 3 multiplied to 7, added to the next term, which is 1 over 7 times 11, added to the third term, that's 1 over 11 times 15. So this is going to go all the way up to the last term or the nth term, which is given by 1 over 4n minus 1 multiplied to 4n plus 3. Now it's given here that it sums up to n over 3 multiplied to 4n plus 3. So this is a equation, but what we have done, we have converted it into a mathematical statement. We need to verify that this is indeed a true statement for any natural number that we pick up. So to begin with, we are going to consider the first natural number, which is 1. So for n equals to 1, what we get is P of 1 such that we only have to consider the first term, which is 1 over 3 multiplied to 7. This is going to be equals to, so we have n over 3 times 4n plus 3. What we'll do, we'll replace the n value with 1. So we have 1 over 3 multiplied to, so 4 times 1, that's 4. So we have 4 plus 3. Now 1 over 3 times 7, that's 1 over 21. And on the right hand side, we also get 1 over 21. So this means that, this implies that P of n, the statement P of n is going to be a true statement if we choose n to be equals to 1. That means it's valid for the first natural number. Now what we'll do, so this is valid for the n natural number, we will suppose that let n equals to m, that is, in essence, P of m is also true. Well, considering that P of m is also a true statement. Now, if P of m is a true statement, that simply means that P of m such that we have 1 over 3 times 7 added to 1 over 7 times 11. So this is going to continue all the way up to the last term, but we have to replace this n with m such that we have 4 times m minus 1 multiplied to 4 times m plus 3. This must be equals to m over 3 times 4 times m plus 3. Fine. So we're supposing that this is also a true statement for n equals to m. Now, using this, we need to show that the next consecutive natural number to that of m, which is simply going to be m plus 1, to show that P of m plus 1 is also, this is also a true statement. Now, if it is a true statement, that means we have to show that P of m plus 1 such that we have the first term 1 over 3 multiplied to 7 added to the next term, which is 1 over 7 times 11. This is going to continue all the way up to the term 1 over 4 times m minus 1 multiplied to 4 times m plus 3 added to, now what we'll do, we'll replace this m with m plus 1 to get the next term. So 4m minus 1, when we replace m with m plus 1, that's going to give us 4m plus 3. And 4m plus 3, when we replace the m value with m plus 1, that's going to give us 4m plus 7. Fine. So this is now going to be equals to m plus 1 divided by 3 multiplied 4 times m plus 1 added to 7. So this is what we need to verify. So how do we do that? So we will be considering the left hand side of P of m plus 1. So we have the left hand side, but luckily for us, so if we consider the first term and its sum all the way up to the second last term, this is nothing but the statement P of m. So we could replace this sum with m over 3 times 4m plus 3 because we've assumed that P of m is a true statement. So we have now and this entire expression replaced with m divided by 3 multiplied to 4m plus 3. And to it, we're going to add 1 over 4m plus 3 multiplied to 4m plus 7. Now we need to combine these two terms. So let's combine them. So we're going to get a common denominator, 3 multiplied to 4m plus 3 multiplied to 4m plus 7, which means that in the numerator we are now going to get 4 times m squared added to 7m added to 3. Fine. Now we will factorize the numerator. So factorizing the numerator, so that's going to give us 4m plus 3 multiplied to m plus 1 whole divided by 3 multiplied to 4m plus 3 multiplied to 4m plus 7. So here we can factor out 4m plus 3 from the numerator and the denominator. Now this is going to be equals to m plus 1 whole divided by 3. Now here we have 4m plus 7, but what we can do, we can rewrite it as 4 multiplied to m plus 1 added to 3. Okay, so this is 1. This is nothing but the right hand side. So let's verify that. M plus 1 over 3 times 4 multiplied to m plus 1 plus 3. Yeah. So this is actually 3 here. So this is exactly the right hand side. So now we have shown that since the left hand side equals the right hand side, this means that the statement P of m plus 1 is true. Now that we have shown that P of m plus 1 is true, we can generalize it. So we can generalize it and we can say the statement P of n, the original statement P of n, is going to be true. So this is going to be true for all values of n, for all values of n belonging to the set of natural numbers. So yeah, so by using the principle of mathematical induction, so we have verified that the given statement P of n, which is this particular equation, this is a true statement.